Hello everyone. Today I am here to explain about topological sorting, which comes under the subject design and analysis of algorithm. So let's begin. So what is topological sorting? A topological sorting or a topological ordering of a directed graph is a linear ordering of its vertices such that for every directed edge, that is u comma v, from vertex u to v, u comes before v in the ordering. The vertices of the graph may represent tasks to be performed, and the edges may represent constraints that one task must be performed before another. A topological sorting is just a valid sequence for the task. Topological sorting is possible only if it is a directed acyclic graph. Any directed acyclic graph has at least one topological ordering, and algorithms are known for constructing a topological ordering of any directed acyclic graph in linear time. So let's see the topological sorting problem. Here is a directed acyclic graph. We have to find the linear ordering of its vertices. So let's begin. So let's see one of the problem. Here it is given one of the directed acyclic graph. We have to find the linear ordering of its vertices. Any linear ordering in which all arrows goes to the right is a valid ordering. So here we can see the all arrows are going to the right. So it is a valid linear ordering. But in this we will see that here it is going to the left. So it is not a topological sort. Next is topological sort algorithm. We'll see the step by step how to sort the given graph. So first we have to identify the vertices that has no incoming edges, that is in degree is 0. Next is we have to identify whether the graph is cyclic or not. If it is a cyclic graph, then we can't do topological sorting. So after identifying the vertices that has in degree 0, we have to select one from such. Step 2 is from the selected vertices we have to delete it, and the outgoing edges also we have to delete it. So here is it how it represents, and we have to put that vertices to the output. So repeat step 1 and step 2 until the graph is empty. So in this graph we see that B is having no incoming vertices, so we have to delete this vertex and edge, outgoing edge from the graph, and put the vertex B to the output. So this is how the graph represents now. Next we see that C and F are having no incoming edges. So we have selected F as F, and we are deleting it from the graph. Now the output we will observe that A, B and F. Next we will select the vertex C, and we will delete the vertex and put it to the output, and we have also deleted the outgoing edges from C. So this is how it represents the graph next. Now we will select the vertex D with no incoming edges and put it to the output, and we also delete the outgoing edges of D. So now we are having the empty graph after selecting the A. Next we see the topological sort algorithm. First thing is we have to store the in degrees of all the vertices into an array. Then we have to loop through till the vertices are remaining in the array. First we have to find a vertex with in degree 0 and output it. Next, reduce the in degree of all vertices adjacent to it. Then mark this vertex deleted. So this is how the topological sort algorithm works. Next, here is an example for topological sorting algorithm. We observe that V1 and V2 have having no incoming edges. So we have selected V1. So we will delete V1 and all its outgoing edges. Now we observe that P2 is having no incoming edges and we delete the vertex and all the outgoing edges from it. So we observe the next graph as like this. Next we observe that V3 is having no incoming edges, so we will delete V3 and all its outgoing edges. So we observe the graph like this. Next we see that V4 is having no incoming edges and we delete V4 from the graph and its outgoing edge also. So the graph represents like this now. So in this graph we see that V5 is having no incoming edges, so we'll delete V5 vertex and its outgoing edges also. So now the graph represents as like this. Now we see that V6 has having no incoming edges, so we delete V6 and its outgoing edge, and we observe that only one V7 vertex is remaining, and the V7 vertex is got moved to the output. Now we are having the empty graph. So this is how what is the topological sort order of this graph. Next is running time analysis. So what is the total time taken for an input graph for sorting? So in order to know that, we have calculated the time complexity of each and every step. So initializing in degree array, it takes order of n plus e. Finding the vertex with in degree, it takes order of n. Next is reducing in degree of all vertices adjacent to a vertex, it takes order of v, and output and mark vertex, it takes order of n. So total time is equal to order of n square plus e, which is a quadratic time. So can we do better than this? So let's see. So we have to, for this we have to initialize and maintain a queue or a stack of vertex with n degree 0. So we have initialized the quick queue with in vertices having 0, that is a and f. We see that a and f are having in degree 0. Next is, now if we remove the a vertex from the queue and move it to the output, then the vertex of b is having the vertices with no incoming edges. So b is enqueued to the queue. So in this way we can have the faster time complexity algorithm. This is how it works. So if we do this in this order, we get total running time as order of n plus e, which is linear. So in this way, we can sort any given graph by topological sorting method. So this was all about topological sorting. Thank you.